Hi, future doctors. Welcome to the next class. In this class, we will discuss about how the tensional force and acceleration when objects connected by strings over pulley on rough surface. So already we discussed this on smooth surface. If M2 is greater than M1, so what is the acceleration and tensional force developed within the string? So whenever it is on smooth surface, what is the acceleration formula we get? A is equal to m2g by m1 plus m2. What is the tensional force we get? m1 m2 by m1 plus m2 into g. Correct? So for this, what will be the small change we are going to get by using frictional surface or rough surface? So whenever this object is moving downwards means what is the tensional force we said? M2G minus M2A or M2G plus M2A. So downwards means minus will be coming because our weight will be decreasing whenever we are going downwards. We will be feeling comfortable, therefore minus I told you to remember. Next, whenever it is moving right side, so back side what will be developed? Frictional force. Now what is the net force on this? Net force on M1 is going to be M1A is equal to right side force T minus left side force T minus F, because it is moving right side, T is greater than frictional force. Next, M1A is equal to T minus, what is the frictional force equation? Mu N. Therefore, M1A equal to T minus mu. What is the normal reaction in this? Normal reaction is going to be equal to M1G. Then what is T? Mu M1G plus M1A. Call it as equation number 2 and 1. So from equation 1 and 2, you can equate these two. Then what you are going to get? M2G minus M2A is equal to mu M1G plus M1A. So you can bring this one that side. So M2G minus mu M1G is equal to M1A plus M2A. Then what is common here? M2 minus mu M1 into G is equal to M1 plus M2 into A. Then what is the acceleration now? M2 minus mu M1 by M1 plus M2 into G. See this formula? You can remember this formula. Just here M2 is coming. Whenever M1 is coming on rough surface, minus mu M1 is going to be coming. So this acceleration you can substitute either in 1 or 2. Then you are going to get tensional force. If you are substituting in equation number 1, T is equal to M2G minus M2. What is acceleration here? M2 minus M1 by M1 plus M2 into G. Now LCM you can take M1 plus M2. Next, M2 into, whenever it is coming here, M1 plus M2, correct? Minus M2 into M2 minus M1. So I am taking this G common outside. Now you can expand M2 M1 plus M2 into M2, M2 square. Here M2 into M2, M2 square, minus into minus plus M1 divided by, what you are going to get? See here we left mu. This mu only is going to play main role, isn't it? So mu M1 divided by M1 plus G. Now these two will be cancelled. What is common you can take? M1, M2 you can take common, 1 plus mu divided by M1 plus M2 into G. So same term is coming, but what is extra term here? 1 plus mu. If mu is 0, this term is going to be coming. So in this, you have to remember this acceleration formula and this tensional force formula. So if it is on rough surface. Now same question on inclined plane, like triangle shape if you are taking, how we are going to get this equation, we will see. Next you can see, one surface is on inclined plane, which is going to be suspended on rough surface. So whenever they give rough surface, here coefficient of friction will be available. Now within this, tensional force is going to be developed. Let us assume this is moving downwards, this is moving upwards. Whenever this is moving downwards, M2 is moving downwards, what is the formula? M2G minus M2E, called as equation number 1. Next, in this direction, which force? M1G sin theta. This is M1. This is already we discussed so many times. M1G cos theta. M1G cos theta balanced by normal reaction. What is the resultant force on M1? So net force on M1 equal to T minus in this direction M1G sin theta plus another force is going to be frictional force. So M1A is equal to T minus M1G sin theta plus this minus, if you multiply, you are going to get here minus. So don't get confused with this minus sign. Minus mu. What is frictional force? Yeah. So directly we wrote F plus mu n. So M1A is equal to T minus M1G sin theta minus mu M1G cos theta. So in place of this, T M1A plus M1G sin theta plus mu M1G cos theta. So equate equation number 1 and 2. Then you are going to get acceleration you are going to get. So M2G minus M2A is equal to M1A plus M1G sin theta plus mu M1G cos theta. So A terms you can bring. So M2G minus M1G sin theta minus mu M1G cos theta equal to M1A plus M2. So you can take common M2 minus M1 sin theta minus mu M1 cos theta into G is equal to M1 plus M2. Therefore, acceleration is equal to M2 minus M1 sin theta minus mu M1 cos theta divided by M1 plus M2 into G. So, on smooth plane, what you got? Acceleration is equal to on smooth plane. So, M2 minus M1 sin theta by M1 plus M2 into G. So, extra term you got here, mu M1 cos theta. If mu is 0, then this is going to become smooth surface. Therefore, if you remember this formula, you can get this, isn't it? So, if you remember this, you have to remember extra mu M1 cos theta. Now, what is the tensional force? If you substitute this A in equation 1, we are going to get tensional force. So, now with previous tensional force, generally we will try to write, this is common for each and everything. M1 M2 by M1 plus M2 into G is also common. Then what will be coming in between? In previous question we got 1 plus mu. Here also we will get, so 1 plus 1 is M1 sin theta, another one is cos theta. Therefore, so 1 plus sin theta plus mu cos theta you are going to get. If mu is 0, 1 plus sine theta. So whenever it is on smooth surface, what is the formula? M1 M2 by M1 plus M2 into 1 plus sine theta into G. So for this M1 sin theta, you got extra term mu M1 cos theta. For this 1 plus sin theta, you are getting extra term mu cos theta. Therefore, final tensional force. So if you want to calculate, means you can substitute and calculate directly. I am writing with logic. In this or in this equation, if you substitute this A, you are going to get same equation. So this is the tensional force whenever one plane is going to be frictional surface or rough surface. So these equations, if you remember, definitely you can solve so many problems in laws of motion. Thank you.